So, good morning. Okay, so I think, hopefully, you can hear me. The stream started, it has, good. Um, People just joined, some starts questions to have a look at. Now, these questions are from those predictions that we looked at before of things that are more likely to be on the paper. Doesn't mean they are, obviously, we know that. So make sure you are going over everything, but you may want to use those suggestions to guide your revision, okay? So, starts questions here to have a look at, and then what we're looking at today is sequences, and then by the end of the session today, I will explain the thumbnail question so you know how that works, or if you think you know how it works, if you're right or not, okay? So, just while people are joining, I'll give you a few minutes to just think about these questions here. How would you work them out? You know, if you don't have a pen and paper next to you, if you're not, able to do them in your head, think about what you would do to work them out, okay? Some of them fairly straightforward, but maybe that first one you would have to do some writing down to work it out, so maybe just think about what you would do. Okay, so yeah, I've mixed in, well, there's a question in this first question is to do with forming and solving equations. I can tell that really from the fact it's got a triangle in it, so I'm going to have to do something to do with area or perimeter, I expect, and also we've got algebra here, so it's going to be something to do with forming and solving an equation. Now, that you might not be able to do on paper. The other two questions you would probably, that first one, you might need paper to do that. The other two you could probably do in your head, okay? And that's the reason really why I put them on there, so just to get you thinking. What would you do for these types of questions? What I'm going to do, because I can see, obviously you can see the back of the printing, can't you? I'll take the rest of the pages away, hopefully that will make it a bit better. It's a bit better, yeah. Okay. Obviously printing double-sided to try and save paper, as you can imagine. We have got, less than 3 days now until the paper 2 exam, okay? So the best practice for, general practice would be past papers, doing as many of those as you can. And I would also suggest you're starting your past papers by doing the June ones rather than November if you do an exam board that does both, because November exam papers are done by essentially a different cohort of students. They're not done generally where the vast majority of people are finishing year 11. November papers are usually done from people doing resits and things like this. So it's slightly, you might find they're ever so slightly different in terms of difficulties and things like that. So yeah, obviously the best thing to practice is the thing that you're going to do, the June paper, and then obviously they are identical papers. Not that you would notice the difference. You might do, you might not. But there might be a slight difference in terms of difficulty, in terms of questions, because of the cohort it's aimed at, in terms of also the grade boundaries and things like that. So I'd recommend doing the June papers first, and then when you've done those, November papers. Okay. Right, so what I'm going to do, I'll get started on working through these questions, because we've got a few more people joined us now. Working out the area of the triangle, we know the area of the triangle, we're not working it out, it's 294 centimetres squared. We've got a right angled triangle. That's handy, because if we need to do the area, you can do it in two ways, can't we? We can do it with the base times the height, perpendicular height, and half it, or we can do half AB sine C, where it's a half of one side times the other side times sine of the angle in between them. That will also work out the area of your triangle. So for this question we need the first option, base times the perpendicular height, because it's a right angle triangle, and half it. So we need, and when you have an algebraic question like this, don't be put off by the fact it's got algebra in it. Do it the way that you would normally do this type of question. Almost forget that it's got algebra in it. Write down what you would do. So a half times by the base, so 4x times by 3x. And that's got to be equal to, because that's our area, 294 centimetres squared. Okay, now we do exactly the same process. We're just going to do it with algebra. So 4x times 3x would be 4 times 3 is 12. X times x is x squared. So we've got a half times 12x squared is equal to 294. And then a half of 12x squared is 6x squared is equal to 294. Then we need to solve it. So what we need to do at this point is divide by 6 on both sides. Okay, so x squared is equal to 294 divided by 6. I'm just doing this manually because I just realised I haven't got my calculator with me for some reason. So I'm going to have to just get one up on the computer in a second, but that's fine. 6 in a 2 doesn't go, carry my 2. Use your calculator for this, don't do it the way I'm doing it now. 6 in a 28, 6, 12, 18, 24, so that's 4 remainder 5. And 6 in a 54 goes 9. So we get x squared is 49, x is equal to 7. Okay. So, the other thing to notice actually, while I'm saying that, x squared is equal to 49. Now x should be equal to plus or minus 7, but you can't have negative 7 because 3 times negative 7 would be negative 21, and you can't have a negative length. So we just have positive 7 as being x. Okay? Right, now the next question is write the ratio 32 to 24 in its simplest form. So we need to find the highest common factor, ideally, to divide both of these numbers by. If you can't find that, just divide by a number that would go into both of them. So if they're even, divide by 2, and then like we're simplifying a fraction, keep dividing both numbers by the same number until you get down to a situation where you can't divide it by any other numbers apart from 1. So I'll demonstrate what I was saying there because it might sound a little bit confusing. Divide by 2 on both sides, so that gives you 16 to 12. Right, I can still divide by 2, so carry on with that. Divide by 2, divide by 2, I'm going to get 8 to 6, and I can still divide by 2 because they're both even again, so I'm going to get 4, divide by 2, sorry, I'm writing the answer, 4 to 3. Now, if we had the highest common factor, which is 8, you could have just divided by 8 and got straight to 4 to 3. Okay. Next question, 1/9 of people in a class are left-handed. Now straight away I'm thinking that means that 8/9 are right-handed. Okay. Write the ratio of left-handed people to right-handed people. So we're doing left-handed to right-handed. Well, left-handed was 1/9. Right-handed people was 8/9. Well, there's a ratio, but we can't have it really as a fraction. You want it as whole numbers, so times both sides by 9 to get rid of the denominators, and then we're going to get 1 to 8. Okay, and that's our answer. Okay. Next question is about error intervals, excuse me. A number y is rounded to 1 decimal place. The result is 14.8. Excuse me. So we need to think about actually, if we went 1 decimal place down, so if you make a kind of imaginary number line, it's only our working out, so I don't need to use a ruler. 1 decimal place down would be 14.7. 1 decimal place up would be 14.9. Halfway in between, we've got 14.75 and 14.85. Now, those two numbers are your lower bound and your upper bound. So if you just go whatever it says it's rounded to, down and up, and then go halfway, that gives you a lower bound and upper bound. Okay, you've just got to remember technically it can't be the upper bound. It can be anything up to it, so it can be the tiniest bit less than that, but it can't actually be 14.85. Now that just changes the way we write down the error interval. So we're doing it for y, that's the letter we need to use. So we got y, and then it's got to be less than 14.85. Okay, anything less than 14.85 would round to 14.8, but it's also got to be greater than, or could be equal to, 14.75. If it's equal to that, it will also round up to 14.8. Okay, if it's 14.75 to one decimal place is 14.8, but 14.85 to one decimal place is 14.9. But anything just less than that would go 14.8. So if I had 14.84999999, that would go to 14.8. Okay, which is why that's a less than, and this is less than or equal to, or depending on which way you round you look at it, greater than or equal to. Okay. So this is for, well, both really, Imam. It's practice questions for foundation and higher. So I'm going through both, and the reason I've chosen sequences is because for first class maths predictions it was on both. So what I do is I start with the easier questions and then we build it up. So we'll start with general, arithmetic, Fibonacci, find the next term type of questions, and then it will go on to quadratic. It will go on to some problem solving questions, and algebra based questions as well. So I hope that helps answer your question. Okay, the next questions are on the other side. So what we're looking at here, and this is from AQA. AQA, if you know or don't know, they do multiple choice kind of questions, and they also have a slightly different kind of layouts. You might be able to tell anyway. Match each sequence to its description. So they've done the first one for you, Fibonacci. Now the reason I put this question first is because I wanted to just run through quickly actually what the different types of sequences or progressions are. So Fibonacci sequence is where you add the previous two terms to get the next one. So 1 add 1 is 2, 1 add 2 is 3, 2 add 3 is 5, 3 add 5 is 8. Okay, arithmetic is where a sequence is going up by the same number or down by the same number each time. Okay, so an example of an arithmetic progression would be 2, and then so you could start with any number. I'm going to go up in threes. So 2, 5, 8, 11, and as long as you go up by the same number, or you could go down, so take away the same number each time, that will be an arithmetic progression or arithmetic sequence. Okay, now a geometric progression or geometric sequence, you're welcome Iman, is a progression where basically you multiply or divide by the same number each time. So again, it doesn't matter which one you start with. We could start with 4 and we could multiply by 5 each time. So 4 times 5 is 20, 20 times 5 is 100, 100 times 5 is 500, and so on. Okay, so geometric you're multiplying or dividing, arithmetic you're adding or subtracting. Triangular numbers. Now this is the type of number that people tend to forget more than the others because it doesn't come up as commonly, but it's basically, if you build triangles with dots and then count how many dots that would take, that's kind of your numbers. So 1 dot to start off with, and then we're going to have 1, and then we put 2 underneath, and you're building it up layer by layer each time. So the first triangular number is 1, then it goes 1, 2, 3, then the next one is that same pattern with another row underneath, so you add 3. So we're going 1, 2, 3, 4, 5, 6, so 1, 3, 6, and then same pattern again, but you add another row. Hopefully you can see this. Obviously me being left-handed it's a bit difficult sometimes. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now when you start to do this you can see that actually what these are going up by, that's going up by 2, that's going up by 3, then we go up by 4, then we go up by 5. So you're increasing by 1 each time the amount that you're going up by. But the way to remember them, the way I remember them is with these triangles of dots and then counting how many you've got. Cube numbers, so that's 1 cubed, 2 cubed, 3 cubed, 4 cubed, and you've got your calculator so you can work that out. 1 cubed is 1, 2 times 2 times 2 is 8, 3 cubed is 27, 4 cubed 64. Square numbers, same thing, but they're squared. So 1 squared, 2 squared, 3 squared, so on. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. So then all we've got to do here is match these up. The easiest ones to start with are the square numbers, so square numbers goes there. Cube numbers, probably the easiest to do next because they have to be specific numbers. Triangular numbers, again, they have to be specific numbers, so that's quite easy, so that's going to go there. And then we've got to work out which one of these two left is arithmetic and which one's geometric. Now, notice here, that goes up by 1 if you're adding, and then it goes up by 2. So it's not going to be an arithmetic sequence or progression. Now if you think about timesing, times 2, times 2, times 2, yeah, and so on. They're all going to be times 2. So that's got to be a geometric progression. And then arithmetic, we're adding 1, adding 1, adding 1, adding 1, adding 1. So arithmetic progression. Okay. Now the next thing is to have a look at things like next term and nth term of sequences. And we're going to start off with arithmetic because generally they're the easiest ones to do and the easiest place to start. So write down the next term in each of these sequences, and sometimes these patterns, they might not be arithmetic, they might be more complicated patterns. Okay, usually they will be quite straightforward. Okay, so what we want to do in this scenario is actually look at what it's going up by, and that's going up by 4, and check that they're all going up by the same thing. Now they are, which is good. So then the next one, add 4, and we're going to get 23. Okay, the next question, we've got 1, 3, 6, 10. Now you could look at the pattern for this and go, well, that's gone up by 2, and then it's gone up by 3, and then it's gone up by 4. Or if you know the triangular numbers, then you know what the next term's going to be. But if you don't, you can work it out. It's got to go up by 5, it's got to be 15. Okay? Right, moving on to some other questions. Start this side. Okay. Here are the first 4 terms of a sequence. Write down the next term in the sequence. So again, same process. That's gone up by 7, then added 7, then added 7. So you want to look at addition or subtraction first, and then if that doesn't work, look at timesing or dividing. But you should notice a pattern. And when we get on to quadratic ones, you'll see that actually sometimes that first difference isn't the same, but the second difference, so the difference of your differences is the same, or there's a pattern there. But that would be, you know, definitely higher, but also it would be a more complicated question to think about, and it'd probably take you a little bit more time because it's, you know, I don't think they've done that before, any of the exam boards that I know of. Write down the next term in this sequence, so add 7, and we're going to get 36. Explain how you worked out your answer. You can just write add 7. Okay, you can write it in words or, you know, symbols like I've done there. The nth term of a different sequence is given by 4n plus 2. Now, nth term we haven't really spoken about so far. You're probably familiar with it anyway. This is an algebraic expression that allows us to work out any number, or I should say any term, the number in that position in your sequence, any term. Okay, so the term is here. If we look at this sequence above, that's the first term, second term, third term, fourth term, fifth term. We'll look at in a little bit how to work this out, but essentially this will give me all I have to do, a way to work out the term, any term I like. I just have to change n to whatever term I want. So if I want the 20th term, 4 times 20 add 2. If I want the 5th term, 4 times 5 add 2. Explain why 32 is not a term in this sequence. Now, what we want to do, and there's a couple of ways you can do this. I think I might have started on the wrong side of this double-sided page, but that's fine, because I'm going to show you the algebraic way to do this. And depending on the question, you will have to do it this way, or you might be able to explain it another way, whether a number is in the sequence. So, if we're given the nth term, we're going to have to do it this way. So we're going to have to say 4m plus 2 is equal to 32. And we're going to have to solve it. And like I've said before, we can plug a number in here for n, and that will give us that term. But if we solve this and we get n as being a number that isn't an integer, isn't a whole number, then it can't be a term in the sequence. It's got to be in between terms, and so it's not in the sequence. So if we take away 2 here from both sides, first of all, we're going to get 4n is equal to 30. And then we need to divide by 4 on both sides. And as we've got our calculator, we can do that. If you haven't, it's fine, you probably do it anyway. 7.5, because 4 times 7 is 28. And then it's 2 more, so it's half of 4, so 0.5. Okay. Explain why 32 is not a term in the sequence. We can just write 30 divided by 4 is not a whole number. So 32 cannot be a term in the sequence. Box that off. Okay. Now, like I just said, there might be another way to do these types of questions, and I want to show you that now. So I'm going to just turn it over, and I want to focus really on this bottom question here, because it's very similar, okay, but subtly different, and there's an easier way to answer basically the same question. So start off, write down the next term of this sequence. So that's going up by 5, up by 5, up by 5. So the next term, add 5, is going to be 23. Explain how you worked out your answer, add 5. Now, explain why 534 is not a term in this sequence. Now, if you look at the sequence, what you notice is the sequence only ends in 3s or 8s. And because you're adding 5, it will only ever end in 3s or 8s. Okay? 534 does not end in a 3 or an 8, so it can't be in the sequence. So, we just need to write something to that effect. Okay? Every term in the sequence ends in a 3 or 8, but 534 does not, so it can't be in the sequence. Okay, so that explains why it's not in the sequence and how I know, and that's all I need to do. I don't need to do that forming and solving of an equation. Okay? Right, now I'm going to go back to this question up here, just because it will also show us how to use this nth term to find a term. Okay, so what is the 5th term? I'll quickly do this. Add 3, add 3, add 3. Add 3 to 19, we get 22. Right, an expression for the nth term. Okay, now, how do we find an expression for this sequence? I want to write the sequence out again. 10, 13, 16, 19, you can put 22 as well if you want. Although, actually, I wouldn't write 22 for this bit, just because that's presuming you've got the first bit right. So actually, forget about that, because maybe it's wrong. It is right, but let's pretend it's not right, just in case in an exam, you know, you did something like this, had this, did the first part, and it wasn't right, and you just made a silly mistake, something like that. So, first term, second term, third term, fourth term. Now essentially what we need to do is work out a way we can get from each of these term numbers, okay, each of our n here, put it in a table, to our sequence here, 10, 13, 16, 19. Now, it's going up in threes, okay? Now, the other sequence that everybody will know that goes up in threes that you learn, you know, when you're very, very young is the 3 times table. And that goes 3, 6, 9, 12. So that goes up in threes, so that's, we're kind of satisfied with that bit. We need to think about how we would get to that. Now, if I times 1 by 3, I get 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. So we can get from our term to the 3 times table by timesing it by 3. So if we do n times 3, we get 3n. Okay, so that would be 3n. Now, how do we get from this 3 times table, which gives us this add 3 property, to 10, 13, 16, 19? Well, we need to add something. Okay, 3 to 10 adds 7. 6 to 13 adds 7. It's getting a bit complicated now, so I'm writing in lots of additions. Usually I wouldn't do this, I'm just explaining what's going on. So, we're taking all of our numbers and we're adding 7 to them. So we need to do the same thing to this nth term. We need to add 7 to it, and we get 3n add 7, and that is in the nth term. So essentially when I do this, I think about the times table. So 3 times table is 3n, 4 times table 4n, 10 times table 10n. Whatever it's going up or down by, that's the number you put in front of the n. And then all I do is I think about, I don't write this all out, I think about the first number. Because all I need to think about is one number, and the first one's the easiest because it's just the number in front of the n. So I thought about 3, and how do I get from 3 to the first number in my sequence? Well, I add 7, and whatever I do for the first one's going to be the same for all the rest. So I just think about what it's going up by, that times table, and then I think about what do I add to that number to get my first term. Okay, so 3n adds 7 is the answer. Now what is the 40th term? For this we need to do 3 times by 40. Replace n with 40 and then add 7. 3 times 40 is 120 because 3 times 4 is 12. And then add 7 we get 127. Okay. Right, now moving back to this page. These will start getting more difficult, so if you're sitting there thinking, oh, this is quite easy, I know all of this, blah blah blah, I get it, but you know, stick with it because these will get difficult in a second. They do. Okay, so a rule for a sequence. This is another type of thing they can do with sequences. They can give you a rule. After the first 2 terms, each term is half the sum of the previous 2 terms. Okay, now this is a pretty tricky rule. Sometimes they give you something fairly straightforward, like double it and add 7, or just double it. Or they give you something which is a Fibonacci one, where they say add the previous 2 terms to get the next one. With this one though, it's pretty tricky. You've got to add the first 2, so we've got to do 2 add 10, and then half it, so each term is half the sum means add, and then we've got to half it of the previous 2. So 2 add 10 is 12, half it is 6. 10, so this is going to be 10 add 6 and half it. 10 add 6 is 16, half it is 8. Okay, now we've got to do 6 add 8 and half it. 6 add 8 is 14, half it is 7. We've got to show the 6th term is the first number that is not a whole number. So we've got to work out these and then get to the 6th one. So 1, 2, 3, 4, 5, 6. So then we've got to do 8 add 7 and half it. 8 add 7 is 15, half it is 7.5. Okay. I suppose what you're doing here is you're working out the average between 2 numbers, aren't you? You're working out the mean, because you're working out the mean of the previous 2 numbers. So this is quite an interesting sequence actually, and it probably would, I imagine it would tend to the same number. It's got to, because you're working out the average of numbers that are closer and closer together. You're working out the average of averages, really, as you're going along. So, yeah, it's quite a nice sequence, that. And depending on the numbers you start with change where your average finished, which is quite interesting. Anyway, moving on. A different sequence. So now forget about that last bit. I said forget about that last bit. Follows the same rule. So don't forget about that last bit because we need the rule, but forget about the numbers. We're going to have different starting numbers. And in fact, the first one's 4, and then the third term is 9.5. Now, work out the second term. What you might want to do here, because we're going to have to do 4, add something, and then half it is equal to 9.5. If we put that gap as x, then we can start working this out. Now, what I need to do is times both sides here by 2 to get rid of that divide by 2 as the denominator. So times both sides by 2. And I'm going to end up then with 4 plus x. So 4 plus something is equal to, now 9.5 doubled, you've got your calculator, but if you haven't, again, pretty straightforward, 19. So 4 plus something is 19. Then we're going to take away the 4 from both sides, so that disappears on the left hand side and we get left with x equals. So 19 take away 4 gives you 15. Okay, and there's the solution to that question, so x is going to be 15. Excuse me. Right, super. Forming and solving again was mixed into that question. Algebra is quite commonly mixed in with loads of different types of questions, so make sure you're confident with that. And you can see on the screen anyway the percentage that algebra usually takes up. So, and this is with Edexcel. This was from. So algebra is usually 30% of the paper. That won't be too dissimilar with the other exam boards. So AQA, OCR, IGCSE. It will be very similar. Okay. Next questions. The one thing we haven't looked at yet is patterns. Now, patterns is something that could come up as well, and basically all you need to do with that is change the pictures to numbers. So basically write down the sequence from the picture. Excuse me. Right, now we've got here circles and squares. So a sequence of patterns is made from circular tiles and square tiles. Here are the first 3 patterns in the sequence. Pattern 1, pattern 2, pattern 3. First question, how many square tiles are needed to make pattern number 6? So we've got pattern 1, pattern 2, pattern 3. We're looking at square tiles, so let's write down the sequence for that. So we've got 1, then it's 4, then it's 9. Now you might notice that actually these are square numbers. The reason for that is because they're making squares. You've got 2 times 2, 3 times 3. So we can carry this sequence on until we get to number 6. 1, 4, 9. So 3 squared, 4 squared is 16, 5 squared is 25, 6 squared is 36. So our answer is 36. How many circular tiles are needed to make pattern number 20? So we've got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 3, 6, 9, 12. Okay, now you can probably work out these are going up by 4, up by 4. Okay, and then it will go up by 4 again. Now that is, in terms of nth term, the sequence that goes up by 4s is the 4 times table, which is 4n. And this also already starts with 4, so it is just 4n. So that sequence is 4n, the 4 times table. So to get pattern number 20, we need to do 4 times by 20, because we're changing n in here to 20. 4 times 20 is 80. Derek says when the pattern number is odd, an odd number of square tiles is needed to make the pattern. So now we're thinking about the square tiles again. So when the pattern is odd, an odd number of square tiles is needed to make the pattern. So in terms of nth term, this is our square numbers, so that's going to be n squared, 1 squared, 2 squared, 3 squared, so on. So we're just thinking about squaring an odd number. Now if I have an odd number times an odd number, does that give me an even number or an odd number? Now we just need to think of an example here. So for instance, 3 times 3 is 9, which is an odd number, so that will give us an odd answer. So and that will be the same no matter what. We don't need to prove this with algebra, so if you've done proof, you might have been thinking of doing it that way. You could do it that way, you don't have to do it that way. The easiest way is just thinking about how the numbers work together. Odd times odd gives me an odd answer, so that's all really I need to write down. I can write this down, that's true. Is Derek right? Yes, Derek is right. As an odd number multiplied by an odd number will always be odd. Okay. And similar, to the reasoning that we did for is this number in the sequence, you can just write it down logically in words like that. Okay, you don't need to use algebra. Okay, now this is all going to be about looking at nth terms, and then we start looking at, well, these are slightly different to arithmetic, you'll see. So if I have a look at this, that's going up by 7, then it goes up by 11, then it goes up by 22 to 37 is 15, then it goes up by, should be 19. Now these differences aren't the same, so you might start thinking at this point, is it a geometric sequence? Do I need to multiply? But because it says nth term, I know with Excel at least you don't need to, and I'm pretty sure with the other exam boards, you don't need to find the nth term of a geometric sequence. You don't need to know that, okay? I'm pretty sure on that. The only exam board you might need to know that for, which I'm not as sure about, is GCSE. You may need to know geometric for that. Okay, so, and this isn't from GCSE, so I know it's not geometric, and it says nth term, so it's not arithmetic. The other one I need to know is quadratic, okay? So, 4 to 11 goes up by 7. These differences are different, but the second difference, so 7 to 11, the difference is 4. 11 to 15, the difference is 4. And 15 to 19, the difference is 4. Now, from that point, what you need to do is half your second difference. Once you have second differences that are the same, half it. That is then n squared. So half of 4 is 2. So we've got 2 n squared. That's the first bit. When the second difference is the same, you know it's a quadratic sequence. You know it's going to be something n squared plus something n plus something, or minus, yeah. The second difference, you half it, goes in front of n squared. Here, what we need to do is substitute in our term numbers. So 1, 2, 3, 4, 5. 1 squared is 1 times by 2 is 2. 2 squared is 4 times by 2 is 8. 3 squared is 9 times by 2 is 18. 4 squared is 16 times by 2 is 32. 5 squared is 25 times by 2 is 50. Now we've got that first bit, we've got 2n squared, we've got the n squared bit. What's left is the something n plus something, which is an arithmetic sequence. So what we need to do is work out the differences. What's the difference between each of my numbers? Because whatever that difference is has to be a linear, another word for arithmetic sequence. The difference between those two is 2. The difference between 11 and 8 is 3. The difference between 22 and 18 is 4. The difference between 37 and 32 is 5. And as you can imagine, 56 and 50, the difference is 6. So we're basically subtracting 2n squared from the original. And we get this sequence. Now that's going up in ones. So that's going to be 1n, but my first number in this sequence isn't 1, it's 2. How do I get from 1 to 2? Add 1. Okay, so what's the expression? What's my answer? Well, I've got to put these three things together. Now be careful, because that isn't minus 2n squared. I've just put subtract there, which is why I left a little bit of a gap. because you could have a negative 2 there if the sequence was going down. Well, actually, strictly speaking, not necessarily if the sequences were going down, if the differences were going down. Anyway, 2n squared plus 1n, or just plus n, plus 1. That is my answer. You need to put the bits together. 2n squared, because that was my n squared bit, plus 1n plus 1. Put it all together is the answer. And to check that, which is what I recommend you do, always check with any questions you can check with, and this is one of them, that it works. So when you calculate it, 2 times 1 squared plus 1 plus 1. So 1 squared is 1, times 2 is 2. Add 1 is 3, add 1 is 4. That works. Try it with another number. Let's try with 3. 3 squared is 9, times by 2 is 18. Add 3 will give us 21. 22. Add 1 will give us 23. Let me check that, because this is definitely right. 3 squared is 9, times by 2 is 18. Add 3 is 21. Add 1 is 22. There you go. Yes, it does work. Okay, the next one tells you it's a quadratic sequence, which is a little bit more helpful because you already know you're going to have a second difference. We need to find an expression for the nth term. So I'll do this a little bit quicker this time. So that's going up by 6, up by 10, up by 14, up by 47, take away 29, that's got to be 18. And you can start to work this out because that's going up by 4, up by 4, up by 4. So this has got to be going up by 22. My second difference then is plus 4, plus 4, plus 4, plus 4. So again, it's going to be 2n squared. I haven't really got a lot of room to write this down. Let's go, we're doing it here. 2n squared again. Now I can just copy this from above because it's got to be the same. 1 squared is 1, times 2 is 2. 2 squared is 4, times by 2 is 8. 3 squared is 9, times by 2, 18. I'm just going to copy the rest. 32, 50, and then don't worry about the last one. You don't need to have that many numbers. Now again, I'm going to subtract that. Negative 1, take away 2. That's going to give you negative 3. 5 take away 8 is negative 3. 15 take away 18 is negative 3. 29 take away 32 is negative 3, negative 3, negative 3, so on. Right, at this point, the difference here is add 0, add 0, add 0, and so on. So in terms of thinking about your nth term, it's 0n. We don't have an n term in this expression. But then how do I get from 0 to negative 3? Well, I've got to take away 3. So, I suppose if you wanted to do it in terms of, the same process we've just done, 0n, take 3, but then we don't need to write 0n. So actually the answer for the nth term here is 2n squared plus 0n, so don't need to write that bit, minus 3. That's your answer. Okay. Right, now the next bit says find the 50th term. It's a bit difficult to see because I've written all over it. Find the 50th term. So we need to do 2 times by 50 squared minus 3. I always recommend putting the number that you've changed n for in brackets. The reason for that is because if it's a negative number, then if you do negative 50 squared and don't put brackets, your calculator will give you the wrong answer. It will square the 50 and then make it negative. Okay? So yeah, just bear that in mind. Now, you might get away with it in this circumstance because you've got the times before, so the calculator would know that that's the operator, and then the subtract means it's a negative number, but that's why the calculator gets confused. Okay, so 50 squared, 2,500, times that by 2, 5,000, take away 3, we get 4,997. Excuse me. Super, so that bit's done. Next question, again it tells us a quadratic sequence. It says find the values of A, B and C. Now I'm going to show you a slightly different method here. The reason for that is some people might have seen this other method, and also some people might find it easier. So I'm going to show you this other method, and it relies upon the fact that you know if it's a quadratic sequence, so if it's got a second difference that's the same, then it's going to be something n squared plus something n plus something, or minus if it's a negative number. So 0, 9, 22, 39. Now, what I'm going to do is I'm going to work out the first term in this. So if n was 1, we get a times 1 squared. So that's a. So the first term would be a plus 1b, so plus b plus c. And now the second term would be 2 squared, which is 4, so we get 4a, plus 2b plus c. And then the third term would be 3 squared, which is 9, so we get 9a plus 3b plus c, and then we would get 4 squared, which is 16a plus 4b plus c. Right, now if you look at this and then you start doing the differences of this, well, that's gone up by 3a plus b. And then this has gone up by 5a plus b. And then this has gone up by 7a plus b, and so on, if you carried on the sequence. Now from there, the second difference, well, that's gone up by 2a, and that's gone up by 2a. So then you can start seeing actually the relationship between this and an squared. Well, the a part is half of 2a. So what you can do is find your second difference and half it. That's your 2a. Okay. Then once you've got that, you can actually work out that your first initial difference is 3a plus b. So between 0 and 9, you get a difference of 3a plus b. And once you've got a, then you can use that first difference, that number, to form and solve an equation to work out b. And then once you've got a and b, well, the first number is just your coefficient, add your coefficient, add your coefficient, a plus b plus c. So what we can write down is second difference is 2a. First, I'm going to put initial actually. Initial first difference is 3a plus b, and you can just learn these and memorise these. And then initial term, so first term basically, is a plus b plus c, and that's all you need to remember, and then you can just form and solve equations. So let's use that with this. So we've gone up here by 9, then we've gone up by 22, take away 9, 13, and then we should have gone up by 17, we have, as long as I've done the maths right, which I have. So that's gone up by 4, that's gone up by 4, and I don't actually need to work out the rest of these. Once I know it's quadratic, I only need to work out 1, 2, 3 differences, because that's enough. As long as I've got the first and the second difference, I can work these out, and the initial number. So, second difference, so 2a is equal to 4, which means that a is equal to 2. Then we've got 3a plus b. 3a plus b is equal to, so that's the initial first difference, so plus 9. So we've got 3 times 2, so 3 times 2 plus something is 9. 3 times 2 is 6, plus b is 9, which means b is 3. Okay, hopefully you can see that. And then we've got a is 2, b is 3. And we've got initial first term, a plus b plus c is 0. So if we now do 2 plus 3 plus something, 2 plus 3 plus c is 0. 5 plus c is 0, so c is equal to negative 5. And then we've got it. All we need to do now is just write it like this. So a is 2, so we get 2n squared plus b is 3, so plus 3n minus 5. And that's it. So you don't need to remember how to do this bit. This bit was just to show you what's going on. Don't need to remember that bit. All you need to remember is second difference is 2a, initial first difference is 3a plus b, and the first term is a plus b plus c, and you can just use those to work out a, b and c of your quadratic nth term. Okay. Right. Hopefully that makes sense. If it doesn't, let me know in the chat. Moving on now to the next questions. So, this is where it gets slightly more difficult. We're looking at forming and solving equations and maybe some simultaneous equations as well. Okay, the nth term of a sequence is given by an squared plus bn, where a and b are integers, whole numbers. The second term of the sequence is negative 2. Right, so what can I do with that information? Like I always say, if you can work out anything while you're reading through the question, do that, because you don't want to get to the end and have what's called cognitive overload, so you're thinking about too many things and then you can't work out anything. So we're going to change n to 2 because it's the second term. Remember, n is your term number. So we've got a times by 2 squared plus b times by 2. Now that has to give me negative 2. So 2 squared is 4a plus 2b is negative 2. That's my first equation. Now the second bit says the fourth term, so n is 4, of the sequence is 12. So we're going to get a times 4 squared plus b times 4 is 12. That gives me 16a plus 4b is 12, and that's the second equation that I need. Right, so I'm going to call that equation 2. Now at this point we need to know how to solve simultaneous equations, and I don't have the same coefficients in front of a's, the same letter, or the same coefficient in front of b's, again the same letter. So I need to multiply one of my equations, at least one, so that I do have the same coefficient in front of either a or b, the same letter. Right, so the easiest thing to do is probably to multiply equation 1 by 2, so that I get 4b, which is the same as in equation 2, 4b. So equation 1 times 2. That gives me, so I'm going to times every number by 2. Equation 1 times 2. So 4a times 2 is 8a plus 2b times 2 is 4b is equal to negative 2 times 2, which is negative 4. And then I call that equation 3. Because it's a new equation, so I've got to label it again. Now at that point, what I can do, I've got 4b and 4b. How can I cancel those out? Well, if I subtract the equations, I'll get 4b take 4b, which will be 0. Then I've got rid of 4b, then I've just got a in my equation, and then I can solve it. So I want to do, think about, if you're doing subtract, which way round you're doing it. Because if I do 8a take away 16a, I'm going to end up with a negative number, which is less than ideal. So I don't want that, so I'm going to do it the other way around. I'm going to do equation 2 take away equation 3. So 16a take away 8a. Now what I'm going to do, actually, I'm going to rewrite this underneath because you'll be able to see it a lot easier. So 16a there plus 4b is equal to 12. That's equation 2. So I'm doing equation 2 take equation 3. 16a take away 8a leaves me with 8a. 4b take 4b is 0. 12 subtract negative 4. Now use your calculator, especially with negative numbers. I mean, I would always use it on a calculator paper 2 and 3. But especially with negative numbers, use your calculator. So 12 take away negative 4. You're going to get, I don't know why I'm doing this on the calculator on the screen, 16. If you subtract a negative, it's equivalent to adding the positive. So 8a is 16, so now if we divide by 8 on both sides to get down to 1a, we're going to get a is equal to 2. Okay? Once you've got a, the rest of it is pretty straightforward. We've just got to substitute, and I'll do this bit over here. Substitute a equals 2 into one of the equations. Usually the ones with the smallest numbers, and positive if possible. So let's go with equation 1. I know that's negative, equals to negative 2, but the coefficients are smaller than equation 2. It doesn't matter though which one you do, as long as you substitute it in right. So 4 times by 2, so 4 lots of 2, because we know A is 2 now, plus 2B is equal to negative 2. So we've got 8 plus 2B is equal to negative 2. Take away 8 from both sides, and we're going to get 2B is equal to negative 10. Divide by 2 on both sides, B is equal to negative 5. Right, we've done that bit. I've just read the question again. It said find the sixth term of this sequence. Now, there might have been an easier way of doing this, just by understanding that it's a quadratic and looking at differences. I might do that actually in a second, just because that might be an easier way of doing this. But having said that, they could have asked you to work out the nth term, so this isn't useless. It's just a longer way of doing it, perhaps. So we know the nth term now is going to be 2n squared minus, because it's minus 5, minus 5m. That's the nth term. Now, if we want the sixth term, it says up here, we need to just plug in 6. So 2 times 6 squared minus 5 times 6. Put that in your calculator. Just kind of box this off if I can. 6 squared is 36, double it 72, take away 30, you're going to get 42. And that's your answer. Okay. Now, the other way we could have done this, I should have grabbed some paper to show you. So the other way which you could have done this potentially, and I don't know this works, but we're going to try it. So the sixth term, we know the second term, so if we do it in a table again, so if we got n, our term number, 0, 1, 2, 3, 4, 5, 6. Okay. And then we put our sequence down below. So the second term is negative 2, and then the fourth term is 12. So we've got a difference here, and a difference here, and then between those differences we've got a difference as well, because it's n squared, it's a quadratic. We also know, because there's nothing added on, that's plus 0, that the 0th term, you might not be aware of a 0th term, but usually you would never have a 0th term in a sequence, it's theoretical. But in terms of writing it down, you could do, but in reality you wouldn't. But it just helps to work out some stuff with the sequence usually. Now this 0th term is always the bit you add on, because 0 squared a plus 0b, and then you add on your number at the end would be this if you substitute 0 in. Now we haven't got anything added on, so that is 0. So again we've got differences, differences, and a second difference here. And then we've also got this second difference here. Now those would have to be the same. Those are the same. Can you work those out? Possibly not. I don't think so easily, having looked at this now. If this wasn't a quadratic, this would be quite a bit easier and you would be able to use this table method. But as it is, because the terms aren't next to each other, it is a bit difficult. If we just, I don't think that's not going to be a whole number. I don't think that one's going to be a whole number. The reason is because it's gone down by something, gone down by, if it is a whole number, negative 1, gone down by 1, but then it's going to go down by more, and it can't, because then it'd be more than negative 2. So I don't think that can be negative 1. If we work it out, what would it be? And this is the reason why it's difficult, is just because you've got second differences. Okay, and you could use the algebra that we went through before to maybe work it out that way, but it's going to be not very nice, because you can't get that A originally, and you can't get the first term either, and yeah, it's going to be very complicated, and you'd end up with something like this anyway. So no, that's not a good method. Okay, right, so I'll leave that there anyway, because that method wouldn't have worked. Right, I'm just looking at how many questions I've got left. Not that many, so what I will do is I will carry on, even though I'm going to go a bit over. The nth term of a sequence is 2n squared minus 1. The nth term of a different sequence is 40 minus n squared. Show that there is only one number that is in both sequences. So 2n squared minus 1. If it's in both, then like with solving equations of straight lines, put them equal to each other. So 40 minus n squared. And then we've got to solve it. So add n squared to both sides. I'm going to speed up a little bit though to get through some of these questions. And I might not do every single one. 2n squared add n squared is 3n squared. Minus 1 is equal to 40. Take away the 1 from both, sorry, add the 1 to both sides. Yep, add the 1 to both sides. And we get 3n squared is equal to 41. Let me just check this. So add n squared, 2n squared minus 1 is equal to 40 minus n squared. Okay. Now the problem I've got here is that solving these equations, 41, unless I'm being stupid, isn't divisible by 3. So that gives us a bit of a problem in terms of this method, because that would suggest that the term that's in both of them is not actually a term in the sequence, because we can't get n. Okay. Right. So there is only one number that is in both of these sequences. Okay. Right, I'm going to start working out what these values are. So 1 squared is 1 times by 2 is 2, take away 1 is 1. 2 squared is 4 times 2 is 8, take away 1 is 7. And then 3 squared is 9, 18, take away 1 is 17. That's gone up by 6, that's gone up by 10, going to go up by 14, and so on. So we'll end up with 31. Excuse me. The nth term of a different sequence is 40 minus n squared. So this isn't going to take too long to work out, because it's going to go past this quite quickly because you're taking away n squared. So the first one, 40 minus 1 squared is 39. Actually, let me carry this on. So that's gone up by 6, gone up by 10, gone up by 14, then it's going to go up by 18. So that would be 41, add 8 is 49. 40 take away 1 squared is going to be 39, sorry, not 49. 40 take away 1 squared is 39. 40 take away 2 squared gives you 36. 3 squared is 9. 40 take away 9 is 31. So the only number that would be in both is 31. We found the number. Let's carry on going through this sequence. And actually, to be honest with you, because it's a minus n squared, just writing down these sequences, because this will go quickly below 0, should be sufficient. But yeah, that method isn't going to work, because the reason why that method won't work is because we're assuming that n is going to be the same place, that they're going to have the same term number, basically. They're going to be equal at the same position in the sequence, which isn't necessarily true. Okay, because see, this was the 4th term, that was the 3rd term. Okay, so just think about another way you could solve that. I'll think about it in a second. I'll finish this off. So that was take away 3 squared. Take away 4 squared is 16. 40 take away 16 is 24. 40 take away 25 is 15. 40 take away, what's next? So 5 squared, 6 squared is 36, so that would be 4, and then you start getting into negatives. So 49, that would be negative 9, and so on. So that would be sufficient, because that's going to get bigger, and that's obviously getting smaller. Now, that method wouldn't work, because it assumes they're in the same place. One number that's in both of these sequences, could you do this with algebra? Possibly. I mean, if you say that 2n squared is equal to 2n, so if you said 2n squared minus 1 is equal to some number, okay, the problem is we've both got n's in, you're going to assume that n is the same. So I think it's going to be quite tricky to do that. Yeah, I think the best way to do that is not algebraically, is actually numerically, and then explaining that, as one sequence increases and the other decreases, working out all the terms, working out all the terms up to the point they cross, to the point the sequences cross, shows there is only one term or one number, I should say, not one term, one number in both sequences. Okay. Right, now I am going to speed this along. I'm not going to do every question. This next one is a spiral pattern, and they form a sequence. So the way to do this is write down your numbers: 1.5, 3, 5.5, 9, 3.5. You need to find an expression in terms of n. That means nth term again. So 1.5, 3, 5.5, 9, 13.5. So that's going up by 1.5. Then we go up by 2.5. Then we go up by 3.5. Then you go up by 4.5. So those first differences aren't the same. It's got a second difference of 1. So that means it's going to be a half n squared. Now 1 squared is 1, half of that is a half, or 0.5 I'll put it as. 2 squared is 4, half of that is 2. 3 squared is 9, half of that is 4.5, and I'm trying to work out the differences of those. So difference is 1, 1, 1, and it will be 1, so on. So all I need to do is a half n squared add 1. So that's my answer. Okay. Right, some quick geometric questions and Fibonacci ones, and then I'll do the answers to these. So, which is a geometric progression? It's going to be one that is multiplying by the same thing each time. So it ends up being this one. All of the terms of a geometric progression are positive. The second and fourth terms are shown. We know it's geometric, so we're timesing by the same number each time. So just by trial and error, that's got to be 2, 8, 16. Work out the first and third terms, that means that's 2. There we go. First three terms of a geometric progression are these. So what am I timesing by? On the top I'm timesing by 2, on the bottom I'm timesing by 3. Or timesing by 2/3 really, the whole fraction. Circle the fourth term, and he said the first term there, the fourth and the first. So times that by 2, times that by 3, that gives me 16 over 27, 54, 81. So 16 over 81. And this question, which is quite a nice question to have a look at in terms of geometric sequences. Now this was on Edexcel. Okay, so if you're doing Edexcel, it'd be quite nice to have a look at this geometric sequence if you're aiming for grade 7, 8, 9, because this is one of the trickier questions. Okay, remember with the geometric you're multiplying by the same thing each time. So work out what that scale factor is. It's got to be the same, set it equal. Okay, find the value of x. So those have to be equal, which should then give you the value of x, because you can then form an equation, solve it, and show the fifth term is that. Okay, I'm going to leave that to you to have a go at if you would like to. Fibonacci, write down the next two terms. You add the previous two to get the next one. 1 add 3 is 4, 3 add 4 is 7, 4 add 7 is 11. Next two terms, 7 add 11 is 18, 11 add 18 is 29. In a different Fibonacci sequence, the fourth term is 31 and the fifth term is 50. Work out the first term. So we need to go backwards. 31, 50, that's the fourth term, that's the fifth term, third, second, first. So we've got a gap here, gap here, a gap here. 50 take 31 is going to give me 19. 31 take 19, add 2, 21, add 10. So that's going to be 12. 19 take 12 is 7. So our answer is 7. If you're going back with Fibonacci, subtract. Second and third terms in the following Fibonacci sequence are x and y. Write down algebraic expressions for the first, fourth and fifth terms. Well, that would be y take away x. This would be x plus y. And this would be x plus y plus another y, so x plus 2y. And then this one, first three terms of different Fibonacci sequence are a, 2a, find the sixth term. A plus 2a is 3a. So that's 1, 2, 3, 4, 5, 6. 2a plus 3a is 5a. 3a plus 5a is 8a. So 8a is the answer to that one. Here's some more questions on triangular numbers and Fibonacci. I'll leave you to do that one at the top on Fibonacci if you want to have a go at that yourself. EdXL this is from. So, 1, 2, 4. Emma says the next term is 7. Explain why Emma may be correct, because that's going up by 1, then you go up by 2, then you go up by 3. The second difference is increasing by 1 each time, so you could add 3 next. Okay, first four terms of the sequence are triangle numbers. Find the eighth term of this sequence. So that's add 2, add 3, add 4. So first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term. Add 5 is 15. Add 6 is 21. Add 7 is 28. Add 8 is 36. There we go. Now the last questions to have a look at, and I'm rushing through this, are nth terms of fractional sequences and the thumbnail question. So, first four terms of a sequence, find the nth term. Now this was from AQA, I believe. I believe it was anyway. Find the nth term of this sequence. Now if you split the fractions up into top, so numerator and denominator parts, and work out the nth term of the numerator and the nth term of the denominator. So, from 1 to 4, that's add 3, then add 5, then add 7. So the second difference between those two is add 2, add 2. So half the second difference, you get 1n squared. And actually looking at these numbers, they are all squared numbers. So on the top we're going to get n squared. Now the bottom, that's going up by 1, up by 1, up by 1. So that's 1n, but it doesn't start with 1, it starts with 2, so 1n add 1. Or just n add 1. And that's it. So that's how you do it with the fractions. Do it for the numerator and then do it separately for the denominator. Okay, they can do it in other ways. They can just do it by, adding arithmetically or geometric progressions just by timesing a fraction by something. But they can also do it this way. So just be aware of that. Now, with the one I've got here, that's add 4, add 4, add 4, add 4. So 4n. But it doesn't start with 4, it starts with 3. So take away 1. And on the bottom, we've got plus 5, plus 5, plus 5, plus 5. So that's just 5n, and it starts with 5, so it is just 5n. So that is the nth term to that sequence. Okay, right, I hope that was useful, I hope that's helped. If there are any questions, please put them in the comments and I'll get back to you. Otherwise, please like the videos, because that tells me that this is useful and that you like the videos that I'm doing, that I'm making. Also, if you want to see more of my content, if you want to make sure the streams come up for you, make sure you subscribe. And of course, if you do want to donate to support the channel, you can buy me a coffee using the QR code or the link in the description. Okay, have a great rest of your day, everybody, and keep working hard. Not long to go now until paper 2. Okay, see you in the next buddy. See you in the next. I nearly said see you in the next one, buddy. Sorry. See you in the next one. Bye bye.